Uh, Sir, should we start?
Yes, I'm ready.
Okay. Good morning, all the dear participants. Today we have with us Dr. C.P. Gupta. Dr. C.P. Gupta will be taking two sessions today and two sessions tomorrow. And we have requested him to cover the time series forecasting. The maximum of the things he'll try to cover. The things he has shared with me is in the this session he'll be talking of introduction to time series and understanding their behavior. In the next session, he'll talk of stationary and non-stationary time series forecasting through ETNA. Tomorrow, in the morning session, he'll be talking of forecasting and volatility through Arch and Garch 1. And in the second session, he'll be talking of forecasting volatility Arch Garch 2. Before requesting Dr. C.P. Gupta to move ahead, I would share something about Dr. C.P. Gupta with dear participants. Dr. C.P. Gupta is presently professor in the Department of Financial Studies, South Campus, University of Delhi. He is MCom, MPhil Finance and PhD Finance from the Department of Commerce, Delhi School of Economics. He has teaching and research experience of more than 30 years. His areas of research, uh, teaching and consultancy include investment decisions, project analysis, security analysis, fuzzy decision making, and financial modeling. He is a member of the Operational Research Society of India, Society for Capital Market Research and Development, Indian Financial Management Association. He has contributed a number of research papers in various national and international journals of repute. He has few research-based books to his credit as well. He guided a number of research students. He is very actively involved in training programs for NTBC, ONGC, ABB, Sapient, XLM, IBM Daksh, among the other organizations. He was a member of the expert group appointed by Government of India to review cost accounting record rules and existing cost audit report rules, is a member of the Cost Accounting Standard Board constituted by ICWI New Delhi. He is also editor of Journal of Indian Business Research. We welcome you, sir, and we are very thankful to you to be the part of this STC program and share your thoughts with us. Now it's over to you, sir.
Thank you very much. Thanks a lot. Okay, before I start, I want to make sure that my audio, video, screen sharing, everything is working perfectly.
Yes, sir. Yes, sir.
Okay, my audio is clear.
Sir, if the voice can be increased a little bit.
Let me check. Is it increasing now?
Yeah, sir. Perfect. Perfect, sir.
Okay. Anything else?
It's okay, sir. It's good.
Okay. So, welcome friends to the session on the time series. And to begin with, let me share with you some good words. Okay. It says, let the things not remain a black box to you. You have to understand that. And that's important. Are students really learning? The noblest pleasure is the joy of understanding. And please understand that as a researcher, you have to make sure that you understand the things. If you don't understand, then you're missing a pleasure, a joy. Okay. So, and also, if you don't understand, you don't get confidence, you are not able to get the visualization of the things. And therefore, I say, whatever you are talking about, whatever you are discussing, whatever you are learning, learn it with understanding. Let it not remain a black box to you. And in this session also, make sure that you are understanding the things. And if you have any doubt, any point of time, you can ask me a question, right? But make sure that you understand the things and things are clear to you. And before I go further, I also like to say that I'm assuming that you know about regression, because time series is little advanced in the econometrics. So basic of econometrics, you know, that's my presumption while doing this particular session. Okay. Uh, Going ahead with that thought of understanding, let me quote the words of Albert Einstein, who said also, if you cannot explain it simply, you don't understand it well enough. And you can also put it like this: if you don't understand it, then you cannot explain it simply. So, friends, if you really want to explain the things in simple manner to yourself, to the audience, to the students, then you have to understand it. And understanding is very, very important. And that will be the focus throughout in our sessions on time series. Understand the things, okay, so that you get confidence, so that you get clarity, so that you can explain them in simple way to others. Okay, so with this thought, let's go ahead and proceed further with the time series. So friends, I welcome you to the session on time series analysis. So let's start with a lot of positive energy and a lot of concentration as well. Okay. What comes to your mind when you see this picture? Sorry. So friends, tell me what comes to your mind when you see this picture. What this boy is doing. Any one of you will like to reflect on it?
The boy is trying to discover or understand something from the grass around him.
Okay. Anything else? You can give your response on the chat box also, no problem. Manpreet is saying deep understanding. Gunjan is saying keen observation. But the point which I'm trying to make here is curiosity. He is curious to know the things. And that curiosity is very, very important. And I believe that all of you are curious to know what a particular thing is. And that curiosity will be there throughout in this particular workshop and in this particular session particularly. So keep that curiosity with you, and that's important for us. Okay. So let's adhere to enter the word of time series. But first, a question: what should we do with data to begin with? First, make a picture, because that picture will help you to think what kind of patterns and relationships you are having and force you to find out what are the reasons behind those patterns and the relations. Second, picture helps you to show various features of your data, including the normality, including the outliers. All those features you can easily capture through a picture or a graph or a chart. Make a picture because it's important to communicate through pictures to others. Because if you have a well-defined, well-designed a graph or a chart, you can communicate so many things to the audience. So friends, whenever you have data in your hand, the very first thing which you have to do is make a graph to get a feel of the data, to understand the data, to appreciate the characteristics of the data, and it also help you in communicating about your data to others. Okay? And that's what we are going to do right now when we proceed with our discussion on time series. Okay, so Let's look at the behavior of the daily closing price of Irving Mills and closing price of Tata Steel Limited, and you will find they are showing different kind of behavior. Why this difference? Maybe you are forced to think about it. Okay. If you look at their normality behavior, you will find their prices are not behaving in a normal manner. So price distribution is not a normal distribution. On the other end, if I take their returns, then this will be the behavior of the return which you will find. And see, there is a difference, sharp difference in the behavior of the prices and in the behavior of the return. And what makes us to see the data differently, the behavior of the data. And if the behavior of the data is different, friends, you can use different tools for their analysis. That's the important message we get when we start looking at our graphs which are being drawn by using data. And you will find out they're very close to normal distribution, but prices were not normally distributed. So you have to take a call. Should you work on return data? Should you work on the price data? Friends, right now I'm not going to answer any question. These are the things that should come to your mind. You should become curious when you see the data and the graph of the data before you. Do you think does periodicity of data makes a difference? It's a daily data, it's a monthly data, it's a weekly data, it's quarterly data. Does frequency of a data or periodicity of a data makes difference in the behavior of the data? If it is so, then what should be the right frequency for your analysis? You have to take a decision about that. Do appreciate the relation between price and volatility, and the you will find as prices goes up, volatility has a negative relationship. Going down, volatility is going up, and that forces you to have a study why that negative relationship we observe between the volatility and price index. Okay, so graph gives you a lot of understanding about the behavior of the data. Say example like this, you have a BSE Sensex data, you have a BSE 500 Sensex data. Both looks to behave in a similar way. If they're behaving similar, then does it make a difference if I use Sensex as an indicator of market or BSE 500 index as an indicator of the market? You have to take a call for it. Do you think that what was that which we were seeing in this graph, do we understand the same? And we have to understand that's a great challenge. Why that behavior? Okay, why there is a different behavior of the prices, return, and stories moving together. What makes them to behave differently, and what kind of analysis you can do by making use of those analysis? That is something which is of challenging to us. Okay, and that's what we have to understand gradually when we proceed in this particular session. So let's start with the first step, and first step is normally the basic step, and that means we have to understand what is time series. Can any one of you tell me what do you understand by a time series? What is a time series?
So data concerning a longitudinal study which incorporates a number of years. in it.
When you say longitudinal study, that's a panel data where you have cross-sectional as well as the time space. So in time series, we have nothing like cross-sectional. It's something which have been observed over a period of time. That's how we understand it. T.D. Gupta is saying that this is something which we collect over a period of time, and that time is normally fixed, year or a week or a day, whatever time you fix it. Okay, that's normally we understand time series. Deals with the statistical data which are collected, observed, or recorded at successive intervals of time. Okay, so yes, all of you are saying that time series is something which have been observed over a period of time. That's normally we understand, and that's the traditional way of defining time series. Time series is a set of observations taken at specified times, usually at equal intervals. So you can have y1, y2, y3. If you take a set of it, that is what is called your time series. Okay, so time series is you can visualize something which is a function of time. Every time is time series supposed to have four components: trend, seasonal variations, cyclical variations, and irregular variations. And traditional theory says that these four components, trend, seasonal, cyclical, irregular, can come in the additive manner and come in a multiplicative manner. Okay, so that's what is being taught in the traditional way of looking at time series. They can have an additive structure like this, or they can have a multiplicative structure like this. Trend, business cycles, seasonal cycles are not influenced by stochastic disturbances. And when I say stochastic, I mean random. I mean probabilistic. So when I use the term stochastic, please understand it. I'm referring to some kind of randomness which is being captured through some underlying probability distribution. Okay, and can be represented by deterministic functions of time. The stochastic impact is restricted to the residuals or your irregular component of the time series. And this irregular component is not having any systematic behavior. It's a noise, does not have any information content, and normally we throw it out from our analysis. Basic assumption about irregular variation is they are erratic, random, unsystematic, and accidental. They are just noise, have no information worth exploiting. That's is one of the basic assumptions when you talk about traditional view about time series. But friends, just give a thought. Do you think that this assumption is a valid assumption? Does it is it relevant with the real life situations? Is it a realistic assumption? Think about it. Traditional view about time series does not help us to exploit all potential of a time series, does not provide us tools to extract hidden information in time series for analysis and for forecasting purposes. And that's one of the biggest limitation when you start looking at time series from traditional perspective. Okay, modern view gives totally a different perspective about time series. Every time series has been thought of as a stochastic process, and that stochastic process is behind its generation. So you believe that there is a machine which is you can say data generating machine, and this machine is generating series which are purely random or stochastic. And because of this, we get what is called a time series. So at the back of every time series, you will find there is a stochastic process which is working and generating that particular time series. So you have a process here. Assume that, visualize that you have a machine working here and generating stochastic processes, and that will lead finally to a time series. If a time series has a trend, then do you think its parameters will be stable? The answer is no, its parameters will not be stable. And if you have a trending series with non-stable or unstable parameters, then how can you make a forecast in future? You cannot do that. So you have to be very careful about handling trend. Trend is good, and we say in the stock market, trend is your friend, but in econometrics, you have to be very careful about trend, because trend may spoil your estimates and does not give good quality of estimates. So be careful about the trend. Okay, and our forecast in that case may not be correct, so be careful about it. Irregular variations may not be noise. Traditional theory says that it's all noise, throw it out. Doesn't have any information, forget about it. But modern theory says no, it's not that. Even that irregular variation which you see in your data may have certain information, and that information can be captured and used for analysis purposes and for forecasting purposes. So don't think that irregular variations are nuisance for us. They can be friend to us, and we can make use of them for our analysis. So everything in a time series may be stochastic, random, probabilistic. Trend may be stochastic, seasonal effects may be stochastic, cyclical effects may be stochastic, irregular variations may be stochastic. Everything in a time series is stochastic. Then the traditional view of looking trend, etc., as a deterministic component is not correct. Okay, and therefore we must change our mindset. We must change our perspective of looking time series from a different angle altogether. So we have to look at a time series with new lenses, new mindset, new perspective, new tools to ensure stability of estimates of our parameters, and new issues. I hope you are ready with this mindset as you proceed further. Okay. Now let's move from traditional way to modern way of looking at time series. Any question now before we go ahead? Any doubt? Any query? No. Okay. Now let's try to understand how we define time series in the context of modern view. But before that, let's understand what is a variable. And then next question is, what is a random variable and how they are different. I hope, friends, you appreciate difference between a variable and a random variable. Can any one of you tell me how do you see the difference between a variable and a random variable? Uh, Many of you are, I think, they are saying no. So I believe that when they say no, that they don't understand the difference between a variable and a random variable. Variable capture data. No, it's not that. That's not the way we define variable, because variable is something that varies. It is not a constant. It's not a constant. This is something that varies. So, for example, if you take income of the people varies from one person to another person, and that what is a variable. If you take marks obtained by the students in a school, that number varies from student to student, that's a variable. Okay, so variable is something that changes, that varies. Uh, Random variable do not have a trend. No. Kamal Kant is saying static and dynamic. No. Random variable is a variable having probability attached to that. What does it mean? Suppose I have a variable x and its probability, say x is my number of numbers when you throw a dice, that may be 1, 2, 3, 4, 5, 6, and you have a probability distribution of it, then x will be called a random variable. Okay, and suppose I take a number of heads. When you throw when you throw a coin number of times, number of heads could be 0, 1, 2, and so on, and you have the associated probability, then this number of head, which is a variable, will be called a random variable. So random variable is one which is having a associated probability. Okay, then we have what is called a stochastic process. So you have a variable v. Random variable is a variable plus a probability attached to it, and a stochastic process is a variable plus probability plus a time dimension attached to it. So if you say x is a random variable, then stochastic process, let's call it P is my stochastic process, that will be the set of x1, x2, x3, and so on. So this set of random variables observed over a period of time is called my stochastic process. Mr. T.D. Gupta is saying a random variable is taking different values, but don't forget when you do some experimentation, you have to attach probability with it. If you don't attach probability with it, then it will not be a random variable, it will be just a variable. Every variable which has associated probability, you can visualize it as a random variable. Manu Pratap is asking me to repeat. I say stochastic process is one where we observe a random variable over a period of time. That's how we understand the stochastic process. Please understand that. If you have a random variable, say prices of a share, prices are behaving randomly. So if you observe prices, price period 1, price period 2, then the set of these prices will be called a stochastic process. That's how we understand the stochastic process. Uh, I've already given you an example of random variable. Suppose we have selected some sample, right? And we have age 20, 21, 22, 23, 24. Suppose I have only this data, right? So I want to know what is the probability that if you select a person from your population, it has an age of 20. So I can assign some probability here, 0.20. So you can say that a person selected having age of 20, its chances are 20%. Then this age, which is a variable associated with the probability, is giving me what is called random variable. And if you add a time dimension to it, then it becomes a stochastic process. So the stochastic process is a collection of random variable xt over a period of time. Parameter t is called the time. If t is discrete, we say we have a discrete series or random sequence or discrete time series. If it is continuous, we say we have a continuous stochastic process or continuous random process or continuous time processes. Okay. Now let's look at this. Suppose I am talking about a random variable x. So x0. Since it's a random variable, it can take any value, and let's assume that x is following a normal probability distribution. So that's the probability distribution of a random variable at 0 point of time. Okay, right? Then this is the value of the random variable at period 2, period 4. So if you take a set of all these, then we get what is called a stochastic process. That's how we understand and visualize the stochastic process. But friends, you might be wondering, where the time series here? I started with understanding and defining time series, but I'm talking about stochastic process. So where is the time series in it? I don't see any time series here. I see a process which is a stochastic process. Okay? Can you imagine where is the time series in it? Okay, I ask you a question. This period had already happened. When it has already happened, Will you get all different values of x? No. You will observe only one value of x. And let's assume that that value is this one. First day. What will be the value of x? I don't know. It can take any value from here to here. Any value can happen. At the end of the day, what we observe, we get only one value at the end of the day. And let's assume that value is this one. Like this, you will observe different values at the end of the day. If you combine them, if you take set of these values, that is what is called a time series. Please understand that. This is your time series. When you take a observed value of a random process, put it together, and that's how we understand a time series. And this is called realization of a stochastic process. And that's what we understand by Mr. Bhanu Pratap. That's not the way we are defining now a time series. We define time series as a realization of a stochastic process. Understand that. I'm repeating my words. Please listen that carefully. Time series is nothing but a realization of a stochastic process. That's how we define time series. Okay, to appreciate further the idea of time series, let me take another example. Suppose we have y, which is a random variable. And assuming, for simplicity's sake, it follows a normal probability distribution, right? So it can take different values with probability distribution, which is normal. Y can take different values. So the set of all this is my stochastic process. But if you observe a point over a period of time and take a set of these points, that will give you a time series. That's what we understand by the time series. So if we are getting different values, and if you take a set of it, we get what is called a time series. So friends, I hope you understand what we mean by time series. Time series is defined as a realization of stochastic process, and we have only one realization out of this large number of values. Please appreciate it. You get only one value of that stochastic process. Okay? And this one realization is the result of some underlying stochastic process. So formally, let's define time series. Realization of a particular stochastic process is a time series. Okay? Every realized observation of a stochastic process is understood as a time series. So stochastic process can generate different series, but if you get one out of it as a realization of the stochastic process, that will be your time series. So this is my time series, which is being observed and realized. Okay. So now let's understand what are the features of a time series data. Time series may be related to their own past. That means yt may be a function of yt minus 1. Okay, it may be subject to deterministic trends, seasonality, cycles, etc. That means yt may be function of time. In multivariate context, they may have cross correlations. That means yt may be a function of another time series xt. Understand this. That understanding is very important. Yt may be related to its own past. Yt may be related to the time, and yt may be related to other variables. Okay, and please remember these things because we are going to use this information later on. What are the purpose of time series? Time series are used for forecasting purposes, estimation purposes, and establishing relationship between the variables. For all this, we need information. You need information for forecasting. You need information for estimation. You need information for establishing relationship. But the question is, where is that information? And where that information is hidden? Can any one of you tell me in the time series where that information is hidden? From where you will extract the information to make a forecast? Can you just imagine? From where you will get the information to make an estimation? Okay, understand that. From where you will get the information, visualize it. Historical analysis, trend analysis, Ajay is saying, Aishwarya is saying data. Of course, data is having information, but in what part of the data you have the information, you have to appreciate that. Okay, so where the information is, now you can see. Suppose I want to make a forecast. I can take the information for forecasting from past values of my series, like yt minus 1, yt minus 2, and so on. So information may be hidden in the past values of the series. Information may be hidden in the time. You can say yt is a function of time. Information may also be hidden in its residual. That means yt may also be a function of its error term. And information may be in some other series, some other time series like xt. Friends, if you know where is the information, you can make a model. If you do not know where is the information, how can you make a model? So you have to understand where is this information. If you have to make a forecast, should you use the past data? Should you use the time to get the trend, etc.? Should you use the error term for making a forecast? Or should you use some other series to make a forecast? You have to take a call where that information is. And accordingly, you have to make your model. Okay? Aishwarya, and I'm really sorry, time series is an advanced course in econometrics. And to appreciate this advanced part, I believe that you have the basic understanding about econometrics. If you don't have it, I'm sorry, you will find a lot of difficulty in understanding what we are talking about. Okay, but nevertheless, I explain what I mean by residual. If you have a regression equation, y is equal to alpha plus beta x plus error term, this error term is giving me residuals. Okay. So friends, the whole fight in a time series modeling is identify source of information. And once you are able to identify proper source of information, then you can have the best module and you can have best estimators. And that's important for us to understand, and that's important for us to appreciate and feel. Okay. So something to be noted, it says everything has been thought before, but the problem is to think of it again with a new mindset. It's not that you are hearing time series or just studying time series for the first time, but we are studying it now with a different perspective, with different mindset. Okay, so that's why I said everything has been taught before, but now the same thing we are looking differently. Now let's understand how do we know what is the behavior of a particular time series? And that behavior you can understand by having a time series plot or a graph of a time series or Corollogram. And that's what we are going to talk about now. Look at this. This is purely random, but it gives you a feel how this is behaving. And you can see up and down, up and down, up and down. And you can also feel that its variation is bounded. It's not going beyond it. It's not exploding, something like that. See here, you have closing prices increasing exponentially, and it will go on like this. Look at this graph. There's a shock. And interestingly, after this shock, the series has come back. And started its own previous path. And this you can appreciate only when you have a graph before you. And what is the implication of it? You start thinking, if there's a shock, come back. If there is a shock, it doesn't come back, what will happen? Say, for example, in this case, there's a shock, but the series has not come back. It is moving away, away, away. So how to model this? That you can appreciate only by looking at the graph. So always make a time series plot when you are working with your data. That's the first thing. Make a time series plot to get a feel and understand the behavior of the time series. Here you see two series which are co-trending, moving together. Very interesting phenomenon. And you will need different tools for modeling them. Graph help us in understanding the behavior of a time series. They help us in deducting whether we have taken right set of data and there is no mistake in it. That can also be found out when you have graphs before you. Another tool to understand the behavior of a time series is Corollogram. But any question before that? It's a plot of the autocorrelations and partial correlations versus time lag of a time series. Corollogram gives you underlying pattern about the relationship between a time series and its lag. What I mean, let me explain that. Okay, YT. How YT is correlated with YT minus 1. I can calculate correlation between YT and YT minus 1. And since I'm calculating correlation of Y series with itself with the lag, this kind of correlation is called autocorrelation. That is correlation with itself but with a lag. Another example, if we calculate correlation of YT minus 2 with the lag 2, then I have autocorrelation with lag 2. And if you study this correlation, you will find underlying pattern in this particular in a particular time series, and it also reveal whether any information is hidden in its past. Okay, and this is the kind of the graph you will get. You have autocorrelation for different lags. So when I say lag 1, that means I'm talking about YT minus 1. Lag 3 means I'm talking about YT minus 3. And for different lags, you will get different values. And you see positive correlation declining, negative correlation which is increasing, that's what it shows. And this is your partial autocorrelation, and I will define what is partial correlation. Give me a time and then I will come back to the partial autocorrelation. And we should also appreciate what is the difference between autocorrelation and partial autocorrelation. Okay, any one of you give me an idea about the difference between autocorrelation and partial autocorrelation? And both are autocorrelation. Please understand that. Y series correlated with itself. That's why we are using the term autocorrelation. So let's move understanding ACF, the autocorrelation function, and partial autocorrelation function of different time series. So we cannot understand and appreciate concept until we experiment and appreciate the differences. Like here, you have a random walk. I will explain later on what we mean by random walk, but understand that there is some stochastic process called random walk. See the behavior here. Autocorrelation is not coming down, and that the behavior of partial autocorrelation. Not coming down, share prices. One time spike, no other time spike. You might be wondering what all these graphs are telling us, but I tell you they have different stories to tell us, and you as a reader must read those stories. Okay, so same that you can see, and if you see the written graph, you will find it has faded out. See here, difference in the behavior, and that difference in behavior will force you to think what you can do with this kind of data. Okay, friends, let's go to Eviews and see how can we make a Corollogram for a particular data. So friends, I hope you have Eviews with you. Open it up. And I just go to File, Open, Foreign Data as Work File, because my data is in Excel, and I hope you people must have got these Excel files. And let me take Reliance Sensex data. Open it up. That's the data which we get. Friends, I hope you are able to open up this file. Anyone finding difficulty? Okay. Suppose I'm working with the BSc Sensex. Open it up. Double click on that. The series will be opened. And then you can make a graph of it. View, graph. That's how you can see the graph. Okay. Now you can see the graph, the behavior of the graph, which you see here is, I don't know what's happening here. Okay, so friends, you can see graph of the Sensex. Okay, so now let's make a Corollogram of it. You go to View, Corollogram, Level, and then you say okay. And that's the graph you will get. Okay, and now you can see and visualize. Just give me, so I can make use of. Okay, if you see the graph, you will find the autocorrelation is, I think I can make. So now friends, you can see this graph. You will find that the autocorrelation is not fading out. And this is the behavior of the And these are the values of the autocorrelation and partial autocorrelation. Okay, is it making a sense to us? Maybe you say no, it's not. And why it's not, we will, because we have not discussed much about it. So let's go for further discussion on it. But before that, I am asking you to calculate return on it. So friends, if I want to calculate return, how do we do it? For that, go to quick, generate series. I repeat, go to quick at the top, select generate series, and we are going to generate series of return. So let me call it return, which is equal to, we will be calculating log returns, log of PSC sensex divided by BSC sensex with a lag. That is the series which we have created. So go to quick generate series and uh, write the equation. Return is equal to log of BSC underscore sensex divided by BSC underscore sensex under root lag 1, so -1. And then you say okay, and you will find a return series is being generated. Double click on it, open it up, go to view, make a graph of it, and you will find that the way graphs look like. See, the price behavior and the return behavior is altogether different. Okay. Now, if we make a Corollogram of it, how it's look like. Look at here, you will find, see, the behavior is altogether different. We do not find any significant correlation which was there in the original series. And that kind of understanding about the behavior you can have when you get Corollogram before you. Pooja Kaura is asking syntax again. I do not know whose syntax you are asking about. Can you please, Pooja, let me know? Pooja, can you tell me, are you asking about syntax of generate series or Corollogram? I don't know. Pooja, what do you mean by the way you have used? Okay, generate series. So go to quick. When you go to quick, you will find the option of generate series. Go to quick, generate series, and then you write the equation. And suppose I calculate return for Reliance. So I define a variable return underscore reliance is equal to log of Reliance Industries divided by -1, and that's how we get the return of the Reliance Industry. Okay, so I hope that clear. So what we have learned is how to make a graph and Corollogram in Eviews. You have to just click, 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 everything will be before you. Okay, so let's go ahead with our study and try to understand what is ACF and what is PCF. These are the formulas that's for theoretical interest. Now let's understand autocorrelation and partial autocorrelation. Autocorrelation is simple correlation between xt and say xt plus h. Calculate correlation between xt and xt with its lag h. That is called autocorrelation. Okay. Now question is, what is partial autocorrelation? Okay. Partial autocorrelation is the correlation between xt, xt plus h, xt and xt plus h after removing the linear combinations of all observations that fall between xt and xt plus h. That means whatever you have here, filter out their effect and then calculate the correlation between xt, xt plus h. That is what is called a partial autocorrelation. Okay, I repeat what I'm saying. If you have a series xt, I simple calculate correlation between xt and say xt minus 3. That's autocorrelation with lag 3. Okay, and on the other end, when I talk about partial autocorrelation, then between xt and xt minus 3. So in between we have xt minus 1, xt minus 2. That means you filter out the effect of this from xt. That means from xt, you filter out the effect of xt minus 1, xt minus 2. And then whatever is left, you calculate correlation of it with the xt minus 3, and that is what is called a partial autocorrelation. Okay, so that's how we understand partial autocorrelation. Then so I hope friends, you are able to understand autocorrelation and partial autocorrelation. And I do not know whether you have observed this thing or not. For lag 1, autocorrelation is always equal to partial autocorrelation. Why? Any one of you, given the reason? Anybody? Why autocorrelation is same for partial autocorrelation for a lag? Because there is nothing in between to filter out. But after lag 1, you will find that there is a difference between autocorrelation and partial autocorrelation. Then In this graph, we have what is called Q statistics. And this is the probability value of the Q statistics. So now let's understand what is this Q statistics. Zung-Box Q statistics is a quantitative way to test for autocorrelation at multiple legs jointly. It's a joint hypothesis. Please understand that. And that joint hypothesis is the null of it is that all autocorrelation up to leg M are equal to 0. Okay. Alternatively, at least one of the autocorrelation is not equal to 0. I repeat, H naught. Autocorrelation 1 is equal to autocorrelation 2 is equal to autocorrelation 3 is equal to 0. That's my null hypothesis. Alternative will be at least one of them is not equal to 0. And it's a test related to autocorrelation and not related to partial autocorrelation. And this follows chi-square distribution. So the statistics is coming, the p values are coming from chi-square distribution. Now let's interpret Q statistics. And it's right. So Mandeep Jant was saying that YAC and PAC for leg 1 are equal. Yes, you are absolutely right, because there is nothing in between. So friends, let's understand this. What does it mean? Null hypothesis is autocorrelation 1 equal to autocorrelation 2. All are equal till autocorrelation 6. And this is rejected. That means at least one of the autocorrelation up to this will be significant. Okay. And similarly, you can have an interpretation of it. Some clarification about Zung-Box Q statistics. Is it possible that once p-value started decreasing, it may increase later on? Yes. And this is because that it's what is called a Portmanteau Test. Now, what is this Portmanteau Test? Is it's a type of statistical hypothesis in which the null is well specified, but alternative is not specified properly. So if you accept null, then your conclusions are strong, but if you reject, your conclusions are not strong. So that is Portmanteau Test, what we mean by this. So be careful about Q statistics. Time series plot and correlation can help us in identification of a suitable model for our time series data. Okay, so by studying this, you can get an idea what should be your model, suitable model for your further analysis. Okay, any question now before we go ahead? Any doubt, any query? हेलो हाँ सोनिया जी बोलिए
Sir, if we can have a break of 10 minutes if you feel so.
Yes, I'm almost at the end.
Okay, sir.
I'm just waiting for any query if students are having it. Okay, so take a pause and recollect what we have done and discussed so far, then we move further. One request to all the participants is please be specific about your question. If you ask me a general question, I'm sorry, I may not be able to answer those questions. So try to be specific what exactly you want to ask me. I will be very happy to answer those questions. Okay, Sujit is asking me, Sujit Mondal is asking me, what is the difference between shock and an outlier? Okay, right. So let me answer this question. If you have a time series and you get a shock here and it has come back, shock means a disturbance, and or you can say outside disturbance in your data. Okay, outlier may exist in cross-sectional also, but shock cannot exist in cross-sectional because shock is an event that happens at a point of time. It just occurs. So we never use a terminology of shock in cross-sectional, but we do use outlier in cross-sectional. Outlier is something which does not fit into my structure of the data. I repeat what I'm saying. Outlier is one which is behaving differently from other data. But shock is something, the whole system gets changed. In outlier, one particular, observation will change and not the whole system. But in case of a shock, the whole stochastic process will be disturbed by it. Okay, that's how we see the difference between a shock and an outlier. Miru was asking me a question. Miru, can you come again? Miru Segal was trying to ask me a question. I do not know what she was saying. Okay. So if you see this autocorrelation is significant, this is not. These are positive correlations. After that, you started having negative correlations, but they are insignificant. And that's the partial autocorrelation. Nowhere significant. And that's the statistical test which we get. So that's how we read it. Okay. So next thing we will be going to talk about in the next session after the break. Until then, if you still have some doubt, you can put your questions on the chat box and I will take those questions. Okay, right? So thank you very much. And we will meet again after the break. So Danny, how much, when we are going to
Participants,
start next?
sir, we'll have off break of 10 minutes only, sir. We want to get maximum from you. 10 minutes break, participants.
You tell me the time when I should start.
Sir, this is 11:26. Will start by 11:36. 11:40, sir.
Okay, so we will start at 11:40. Good. Thank you.
Yes, sir. Thank you. Thank you, sir. Should we start, sir?
Should we start?
Yes, sir. Yes, sir.
Okay. So friends, welcome back after the break, and again some thoughts to begin with. It says if you torture the data long enough, nature will confess. It's a very important message for all the researcher. If you go on torturing your data, something or the other will definitely come out. But will that make a sense? Is that according to the theory? As a researcher, please take a call on it. Please don't torture your data to get something or the other. Get only that which makes a sense. Get only that which is supported by underlying theory. Otherwise, don't torture your data. That's what it says. If you go and doing it, kuch na kuch to hoga. Lekin, will that make a sense or not? You have to take a decision about it. Okay. So be careful about when you start torturing your data. Life can only be understood backwards, but it must be lived forwards. Time series data is historical, but we are going to use it for futuristic purposes, futuristic decision making and policy making. Okay, so friends, with this two thoughts, let's have a quick look. Let's move ahead with something interesting, and sorry, let's have what we are going to talk about. And we were talking about time series in the earlier session. Let's have a quick discussion about it, as I can skip. We define time series as a realization of a particular stochastic process. That realization is called a time series. Every realized observation of a stochastic process is understood as a time series. Okay, so we have a stochastic process and we realize these observations, and then we get a collection of it. That's what is called a time series. Okay, and these are the features of the time series. It may be related to its own past, may be related to trend seasonality, may have relations with other variables. We discuss the purposes for which time series are used for forecasting, estimation, establishing relationship, and for all this you need information, and you have to take a call where that information is. Did the hidden information may be in time, own past, own residuals, or in some other series. So these are the four broad sources of information from where you can extract the necessary information, and then you can make your model and do the analysis. And we said that there are tools to identify the underlying behavior of the time series plot, and Corollogram. That's the example of time series plot, and that's the example of the Corollogram. Okay. We try to understand the concept of autocorrelation, partial autocorrelation, Zoom box Q statistics. Simple correlation between Y and its lag. correlation between yt and say yt minus 3, filtering out the effect of yt minus 1, yt minus 2. And this is the statistics which is used for testing null hypothesis that all the autocorrelations are equal to 0. So these were the things we were discussing in the previous session. Any questions, any doubt? If you have, you are most welcome for it. Any question, any doubt?
Good afternoon, sir.
Good afternoon.
I'm Dr. Meru Segal here.
Right.
When you drew the chart between autocorrelation and correlation, a partial correlation, how do you draw the inferences from that? There were a set of 4 sets of figures there. Just one example, if you could, explain through one example.
Okay. Suppose I calculate autocorrelation like this, right?
Right, sir.
So autocorrelation, partial autocorrelation, these are the graphs, right? And this 1, 2,
Right, sir.
3, 4, these are the legs for which autocorrelation and partial autocorrelations are calculated. This is the column
Fine,
of autocorrelation. This is the, what I do, I copy from here and paste here. This is the autocorrelation and partial autocorrelation, right?
Right,
Okay.
sir.
Right. Any doubt about up
Right,
to
sir.
this?
No, sir,
Okay.
no.
Then what is right? What is what's the question? Is the reference clear or not?
Yeah. No, by figure wise, sir, it is clear. But what does it
Okay.
signify, those figures? How do we
Okay.
draw
Okay.
inferences from that?
Right. But what inference we need? You have to first be careful about it. We are trying to find out whether the YT is correlated with its own legs, say 5, for example. So we are trying to find out the correlation between them.
All right, sir.
Okay. Now there are 2 ways to do that. One is you ignore what is in between, take a simple
Right.
correlation. That's autocorrelation. Okay. Now what is the implication of it? When you ignore it, you know what happens? YT impact is carried to YT minus 1. YT1 impact is carried to my YT minus 2. Impact is carried to YT minus 3. So impact is carrying forward. And all these impacts are being accumulated when I say autocorrelation. Okay. But when I calculate partial autocorrelation, then
So, sir, I'll just
all
interrupt you
what
in
you
between.
have in between. Yes.
Sir, I wanted to ask you, in what situation, say, for example, in petrol prices, is autocorrelation important or partial correlation important? I'm just picking it up from there.
No, you are asking me a wrong question.
All right, sir.
Please understand. First, you must understand the concept.
Right,
okay?
sir.
Second thing is, I'm not telling you what for we are using AC and PAC.
All right.
The reason is because we are not going to talk about these things right now. We are just trying to understand data. We are not going to get any inferences out of it. Okay.
All
but if you want, I can give
All
you
right.
where we use it. Okay. Where we use it.
Right.
We use AC structure and PSC structure to make a forecast of, say, oil prices.
All right.
Okay. Now, question is, when I forecast oil prices, I need information.
Right, sir.
From where you will get that information? You say data.
BSc, right, right.
One option is other series. Suppose we don't have other series. I have only oil price series, and on the basis of that, I want to make a forecast. So what should be my model? That is something we have to look at. So do you say that the information I need to predict oil price, is it in its past legs, or is it in its residual term or the error term? Where is that information? PAC and AC helps you in identification of that information. PAC says that information is in its lag. And error term and AC autocorrelation says information is it in residuals. So I should make a model. If they are coming to be significant, I should make a model of YT, which is a function of YT minus 1 or ET minus 1. There we make use of AC and PAC in order to identify where the information is hidden. Is that clear? And why I say like this, because if you say that information is being carried from period to period, from this period to this period, information is being carried and the impact is being traveling. Now the question is, what is that which carries forward this effect? Can any one of you guess it? What is that carrier which take it forward? And you will find this relationship is being carried forward through error term. So that means error term has information. Use it. And that what you will get to know from AC. Okay. If you have YT minus 1, YT minus 2, suppose there is a relation between these two. That relation you have filtered out. Then what is, now you get this. If you do not get any relationship between YT and YT minus 2, that means the relationship is only with lag. Once that is being taken care of, nothing is being carried forward. That's the significance of partial autocorrelation. Meru, I think you are able to understand that.
Yes, sir. Thank you. Yes, sir. It is very much clear. Very much clear. Thank you so much,
Good.
sir.
Good. Okay, now let's look at again some interesting graphs of the time series. Look at this graph. And you must be wondering why I'm saying interesting. इसमें क्या interesting है? इसमें क्या खास बात है जो इस graph को interesting बना रहा है? And if you start using this graph to make a prediction, what you will get out of it? Think about it. I'm not going to answer it right now, but I will definitely answer when I proceed further. Graph देखिए आप. If you see this graph, what's interesting about it? what's so unique about this particular graph. And if you start making prediction on the basis of it, will you face any problem? Look at this graph. Trending graph. Okay. And if you make a prediction using it, what will be the problem you will be facing? Okay. This is also have some upward trend. This is also have some upward trend. But the nature of the trend is different. And that you have to appreciate that difference in the nature of the trend. And this series doesn't have a trend, and you have to take care of it. Okay. Why should I bothered about time series, which is like this? If we use OLS, can we get blue estimates in this series? You have a time series and you want to estimate a model like YT is equal to alpha plus beta YT minus 1 plus error term as a time series model. And if I use OLS in it, the ordinary least square method, then will you get blue estimates? The best linear unbiased estimator. Yamini Yadav, Hardeep Singh, all are saying no. But the question is why? Why the estimates will not be blue estimates? I agree with you, Dr. Deep and Yamini Yadav, that the estimates will not be blue estimates, but we should also know the reason why they will not be blue estimates. Why? Yamini is saying because independent variable is lag dependent variable. No, that's not the problem. Dependent variable can have its own lag in the model. That's not a problem in time series. And please mind why my words I'm saying in time series. In panel data, it may create a problem, but in time series, it doesn't. Dr. Ratip Singh is saying because stationary of time and but the question is why the stationaries are, why the things are not stationary. Anyway, I'm not discussing about stationary and non-stationary because that's what we are going to talk about. But blue we will not get because there may be a problem of autocorrelation. There may be problem of heteroscedastic, and because of all these problems, you will find OLS will not give you the best result. Then what is the way out? Should you transform your data to get the blue estimates? Should you change your model to get the blue estimates? What should you do so that you will get blue estimates? That's the challenge, you know. We have to confront with and come out with the solution. OLS gives a blue estimate when its assumptions are true, and most of the time you'll find assumptions related to homoscedasticity and autocorrelation are not true. And the culprit is non-stationary behavior of the data. Okay, so that takes us to the discussion of non-stationary. What if you perform regression analysis on the non-stationary time series? You'll be in trouble. You will not get the best estimates. You will get what is called a spurious regression. Results with no meaning. Okay, results with not best estimates, then we say you are going to get some kind of a spurious regression. Okay, so remember, if you work with the stationary, if you work with non-stationary series, your results of the regression where you are making use of OLS will be spurious results. Okay, and this message should be clear and loud in your mind, and therefore never work with non-stationary series. However, there may be some exception to this general rule. I'm not going to talk about the exceptions, and the basic rule is never work with non-stationary series. So for example, if you have two non-series and two non-stationary series like this and this, and you try to get a best fit of line, then you may not get the right results. Like here. So if you take, if you make this series stationary, then you may get some sense out of it. Otherwise, you will not get the sense out of it. To get consistent forecast and other results, one must ensure that the series is a stationary series. And friends, that's what we are going to talk about. The concept of stationarity. So, Dr. Hardeep, can you tell me what you understand by stationarity of a series? When you will say a series YT is a stationary series, any one of you can give me an idea? No, Dr. Deep, that's not the way. The value of in time period 2 is dependent on time period 1. That's not the way we look at and understand stationarity. Okay, that's not the way we define stationarity. Mean and variances are equal? No, that's not the way we define stationarity. When the series is not having trend, of course, presence of trend. So Jita, presence of trend is the cause of stationarity, but it's not the meaning of stationarity. Okay. Yes, Yamni is right. The mean and the variances are independent of time. Then we talk about stationarity. But this is a crude way to understand it. Now let's formally define stationarity. So stationarity is an idea which talks about stationarity of your parameters. And we have two kinds of stationarity, weak and strong. First, we'll talk about weak stationarity. A time series is said to be weakly stationary if it has a constant mean, has a constant variance, and covariance function depends on the time difference between the values of the variables. If they are all constant, then we say a series is weakly stationary. Mean is constant and finite. Variance is constant and finite. Covariance between yt minus 2 is same as the covariance between yt minus 1, yt minus 3. See, the difference is 2 lakhs. Covariance between yt minus 5, yt minus 7, and so on. But covariance of y t minus 1 may not be equal to the covariance of yt minus 2, yt minus 5. And this is not related to our condition. Same lags, if the covariances are same, then we say weakly stationary. Okay, so now let's have a formal definition. The expected value of yt, the mean, less than infinity, that is finite. Variance, finite and constant. Covariance is also finite and constant. This is weak stationarity is called second order stationarity or covariance stationarity. Okay. Jan Thuda is saying mean reverting, and that's the characteristic of a stationary series. That's not a part of definition, that's a characteristic. That series should be mean reverting. That's the characteristic of a stationary series. Okay, right. So in economics and finance, we are concerned with weak stationarity. That is to say, if your series is weakly stationary, then we are done. We are not supposed to look for anything else. So in that case, we use the term interchangeably weakly stationary and stationary, because all analysis in finance and economics can be done if your series are weakly stationary. Okay, because most of the time we work with the two parameters, the mean and the variance, and the second order movement, that is the variance and the covariance. Okay, so if friends, if your series are weakly stationary, then you are done. You need not to worry about strong stationarity. Strong stationarity is saying that the joint probability distribution should be same. So when I say probability distribution should be identical, then I mean mean should be same and constant. Variances, covariances, skewness, kurtosis, shape of the distribution, everything should be identical and same. Then we say we have strong stationarity. We hardly work with strong stationarity. We normally work with weak stationarity. In our discussion, if my series is weakly stationary, we are happy with it. And we will say stationarity. So weak stationarity and stationarity, we are going to use these two terms interchangeably. Okay, so please keep that thing in your mind. Jayant, let's have a look at the characteristics of a stationary process. It's a mean reverting process. That means if there is a shock, the series will come back. Finite memory, that means your graph of ACF will not be like this. Finite memory means it will fade out gradually. The impact of a shock dies out with time, and it has a finite variance. So these are the characteristics of a stationary time series. Let's take a pause and think. Remember that a time series is one realization. I'm underlining the word one. Realization out of many possible ones. Then how can we make sensible inferences on the basis of underlying time series, which is having only one observation at a point of time? Don't you wonder it? It doesn't wonder you. Just think about it. One observation relies at a point of time, and I'm going to generalize it for the whole period. How is that possible? Just think about it. And I want your response in this regard. Anyone would like to react to it? To get meaningful and sensible inferences from a time series where we have one realization at a point of time, we have to have a very strong assumption, and that is of stationarity. It's a very, very strong assumption. And many times you may have to pay a price for this strong assumption. Nothing comes free, no free lunch. If you want to get meaningful results, we are imposing an assumption of stationarity, but that will come at a cost. Okay, right? What is that? Maybe we appreciate further. This assumption treats the time series as a random sample from the same underlying population or process. Okay, what does it mean? Let me try to explain to you through this graph. Understand it. What is it? You have a stochastic process. And all are having same mean. If you see, they have a same mean. And you will also observe that they are having same variance and their distributions are identical. Okay, so series is the process is a stationary process. If you take one observation from here, here, and put them together, what will be the underlying distribution of that particular set? Can you imagine? What will be the distribution of these observations collected? Will it be same or different? Hardeep Singh is saying CLT will play a role here. CLT is a different thing. It doesn't play a role here. CLT talks about the normality of distribution of means if you have larger samples. Okay, so here we are not talking about size of a sample. We're talking about one observation at a point of time. So I'm sorry, CLT had nothing to do with stationarity. Okay, I repeat my question. If you take these observations and put them together, will you get the same distribution or a different distribution? Sujit is saying it will follow random walk. I'm sorry, we have nothing to do with the random walk because I do not know what is the process. It may be random walk, it may not be random walk. I don't know. See, if you take these observations and then you will find you will get the same distribution. So if your process is stationary, then the resultant time series will also have the same distribution. But if you have a stochastic process which is not stationary, like you have this distribution, this distribution, this distribution, this distribution. If the distributions are not same and you pick one observation from them, then what will be the resultant distribution? Resultant distribution, I don't know, because how finally it's going to take a shape, I do not know, because the data generating process are altogether different. It's not same, and you may not have a same distribution, and resultant thing is that you may not get any meaningful inferences out of it. So if you want to retain the original structure of the population, you have to make a strong assumption that your distribution is a stationary distribution. Friends, who is culprit at the back of the non-stationarity? Sujit, now you give me an answer. Trend, yes, you're absolutely trying. It's a trend which creates a non-stationarity in the data. So that's the culprit, and you have to take care of trend. Okay. So please understand that it is the trend that creates a non-stationarity problem in my data, and you have to take care of it to get a stationarity of the data. Okay, friends, before we move further, let me introduce the concept of random walk, because random walk is closely associated with the stochastic process. Okay, right. So any comment on the walk of this gentleman? You will find this gentleman is walking randomly, and that takes us to the concept of random walk. Look at this. Can you predict what will be the next step of this gentleman? It may have next step anywhere. That means this person is having a random walk, because you do not know where is next, where will be its next position. Okay, so that's what we mean by, that gives you feel about random walk. So the classical example that you will find in literature about a random walk is there is a lamppost, and there is a drunkard person who is moving around a lamppost in a zigzag manner, in a random manner. The walk taken by this person is can be termed as a random walk. Okay, right, friends. Many of you were coining the term random walk, but what exactly you mean by random walk? Can any one of you explain to me? Sonia, how do we understand random walk in finance?
Sir, past cannot be used to predict the future. In the random walk hypothesis, we have the three forms of the market in the finance: strong,
That's not
semi-strong, and
Sonia. Make a correction here. It's not a random walk hypothesis. It's a efficient market hypothesis.
yeah, it's the efficient market hypothesis. Sorry, sir.
Don't say random walk hypothesis. Okay, so the weak form, semi-strong, strong, these are the forms of efficient market hypothesis. But in a weak form, we say if market does not have a random walk, then we have a weakly efficient market. But how do we define random walk? And every stochastic process may not be random walk. Please understand that. Prices may have random walk, but returns may not have a random walk. Understand that. Okay, now let's try to. Yes, Nilesh is right. You cannot predict the next step. Then you can say that it is having a random walk. Now let's formally define it. Suppose I have a regression model, yt is equal to yt minus 1 plus error term. Then I can put it as yt minus 1 is equal to error term. Delta yt is error term. What are the properties of this error term? Any one of you tell me? It's random, and independent, and identically distributed. So it has to be what is called ID, independent and identically distributed. If the difference or the change is random, independent, identically distributed, then series is said to have a random walk. Please understand that. Homoscedasticity of that's one of the assumption of the error term. It should not have autocorrelation, independent. That's another, and it should be having a same distribution, identically distributed. Okay, right. So that's what we mean by this. If change in a series is random and independent and identically distributed, then yt will be said to follow random walk. Please understand that what I'm saying. If a change in a series is unpredictable, random, independent, identically distributed, then the series is said to follow a random walk. So I hope this definition is clear in your mind. So when we say prices, say for example, price of Reliance at period T and price of Reliance at period T plus 1, if they are independent, that means the change is independent. That means T is not predicting T plus 1. And that's what Sonia was trying to say, that past cannot predict the future. Okay, so if you have a series PT is equal to PT minus 1 plus error term, then the best forecast for tomorrow is the expected value of PT, and that's equal to the expected, because this is going to be 0 on an average. So the best prediction of tomorrow is the today's price. And that's how you can, Sonia, link it with the concept of efficient market hypothesis that says all available information is
Information.
reflected in share prices.
Prices.
Yes.
Yes, sir.
So is random walk a stationary model? That's again an interesting question. Is random walk a stationary process? Yamni Yadav is saying yes, it's a stationary process. Anybody else? Sujit is saying no. Hardeep is saying no. No. Majority is no, but I do not know. Why? Yamni, what makes you to say yes? And what Sujit, Hardeep, yeah, and Shani. Yes, first difference of random walk is stationary. But why random walk is not stationary? Any guess? Anybody can guess why the random walk is not a stationary process? Hardeep is saying average and the variances are not constant. But why they are not constant? Why they are not constant? Let me take a random walk. Yt is equal to yt minus 1 plus error term implies that delta yit is equal to error term. And assume the variance of the error term is sigma square. Okay. Before we proceed further, so what is the variance of x plus y when x and y both are independent of each other? Any one of you give me a guess? What is the variance of x plus y when both are independent? Sonia, recall your portfolio theory. Because distribution is not clear? No, that's not the question. That's not the answer. Ajay, that's not the right thing. Uh, I do not know how many participants are from finance background. If any one of you are from finance background, please say yes on the chat box. Right. So many are Hardeep. I want to know if I want to get the variance of x plus y, x and y both are independent, then this will be equal to what? It will be equal to variance of x plus variance of y. So if you take lags of the series lag 1, 2, 3, 4, and so on, the variance of it is the first, say, square 2. So every period has the same variance. So what is the variance of lag 1 plus 2 plus 3 plus 4? You will say this is equal to 4 times this. And if you generalize it, you will get n. And when n tends to infinity, variance explodes. And that makes the series a non-stationary series. Right, Radeep, you are absolutely right. At the moment you say n times variance, that means time dependent and it may become infinite, and therefore random walk is always non-stationary. Okay? Yes. Right. So this is a random walk, example of a random walk. We have an example of a random walk with a drift. Drift is your trending term in a random walk. So you can see there is a trend in it. So it's a random walk, but with a drift. Random walk with a shock. Since it is non-stationary, it will not come back. It will move away from that particular level. Okay. Any question before we go ahead? We try to understand the concept of stationarity and concept of random walk. If any one of you having any difficulty, any issue, you're most welcome for it. Any question? No. So if there is no question, then I have a question for you. Normally, you will find prices are falling random walk. And you can define it as PT is equal to PT minus 1 plus error term, or delta PT is equal to error term. And we know that the changes in prices are an indicator of the return. Okay, so is it the return that follows random walk, or is it the price that follows the random walk? I want to ask a question for you from you, or both are following random walk. Adip is saying price, Mandeep is saying prices. Yes, you are absolutely right. It is the price that follows random walk, because change in price is independent and identically distributed, random, and therefore prices are following random walk and not the return. Because many times students get confused whether the prices are following random walk or the returns are following random walk. It is the price that follows random walk, but we define random walk in terms of change, that is the return. Okay, now the question is, once we have understood the concept of stationarity, now the question is how to test stationarity. To understand stationarity, I will be taking a model which is called AR1 model, that is auto regressive model. So I'm regressing y with y, and therefore I'm using the term auto regression. And since I'm using leg 1, I'm calling it as a AR1 model. And my AR1 model is YT is equal to alpha plus rho YT minus 1 plus error term. Okay, is that clear? If I calculate the expected value of YT, you will find it's equal to this one. If I calculate variance of it, you will find it's equal to this. And if you calculate covariance, that's equal to this. I'm not going into proof of these derivations, but if you try yourself, you can get it. It's not a difficult exercise. Friends, I don't know whether you are wondering why I'm talking about AR1 process, why we have a discussion about AR1 process. One reason is for simplicity, because AR1 process is a very, very simple model. Second, and the main motivation for discussion of it is to understand the testing procedure of stationarity. Please understand that. That's the main motivation for me. Testing the understand the logic behind testing procedure of stationarity. We have seen that the expected value of yt should be equal to alpha over 1 minus rho. Friends, what you need to have a series stationary, mean should be constant and finite. It should be less than infinity. Alpha is constant. And therefore, because of alpha, you will never get infinity. This is something you have to take care of. If rho is tending towards 1, what will happen? Think. If rho is tending towards 1, then what will happen? That means your mean will tend towards infinity and the series will not be stationary series. That means I have to impose a condition, and that is the value of the rho should be less than 1. If it is less than 1, then I can think of getting a finite value of mean, and thereby I can think of stationarity. Otherwise, I cannot. Okay, right? Another thing which you must appreciate. Look at this variance equation. In variance equation, if rho is tending towards plus infinity, tending towards 1, what will happen to your variance? Your variance will become infinite, and the process will be a non-stationary process. Okay, what if rho tends to minus 1? Again, it will tend to infinity. Can rho be less than minus 1? Like rho is equal to minus 2. Is that possible? No. Hardeep is saying no. Yes, you're right. But why? Why it cannot be negative? Why it cannot be less than minus 1? Hardeep ji, boliye. Why it cannot be less than minus 1? It should be between -1 to +1. You're absolutely right. But why it cannot be less than 1? If it is less than 1, say -2, for example, then your variance will become negative, which is not allowed. And therefore, the value of the row should be between, should be between -1 . The moment it has a unit value, then the series will be non-stationary. It should not have a unit root or unit value. Okay, so now what I'm doing is I'm trying to establish a connection between stationarity and unit root. If a row is having absolute value 1, then series will not be stationary. If it is less than absolute value 1, then it will be stationary. That means if a series is having unit root, it will be non-stationary. If the series is not having a unit root, that is stationary. So I hope this concept is clear to you. And that will connect us to the concept of unit root and stationarity. And to check unit root stationarity, we have a Dickey-Fuller test, augmented Dickey-Fuller test, and the Phillips-Perron test. Okay, let's see under what conditions you can make use of these tests. Dickey-Fuller test presumes that error term in the module is not correlated, while augmented Dickey-Fuller test presumes that error term in the module may be correlated. There may be some autocorrelation. On the other end, the Phillips-Perron test presumes that error term in the module are correlated and as well as they are heteroscedastic. So friends, depending upon the behavior of the time series data which you have to apply a suitable test. And most widely test is augmented Dickey-Fuller test, which is popularly called Adf test. And in all the three tests, the null hypothesis is series is having unit root. That means series is non-stationary. Alternatively, the series is stationary. Okay, so I hope the null and the alternative hypotheses are clear to you. So let's note the assumptions about this test. Dickey-Fuller test presumes error terms are not correlated. Error terms are correlated, and this assumes error terms are correlated as well as they are heteroscedastic. Okay, so accordingly you can apply the test, but the widely used test is ADF. So let's go to Eviews and try to appreciate the unit root test. Okay, but before that, if any one of you have any question, you are most welcome for it. Any question, any doubt? Please open up your Eviews. We'll work on the same data. Okay, Hardeep Singh, yes, no question, good. Anyone else? Okay, so Let's go back to our Eviews. Sujit Mondol is asking me to repeat the AR1 process. Okay. AR1 process says a series is regressed with its own one leg. This is my AR1 model. And series YT is said to be stationary if the absolute value of the row is less than 1. Otherwise, the expected value of the YT, variance of YT, covariance of YT and YT plus S, they may not be finite. And as a result, the series will be a non-stationary series. So I think, Sujit, that's clear to you. Okay, right. Since I'm not getting any other question, let's move further to Eviews. Please open up the Eviews. I have the data with me that is of, BSc Sensex. So I close it. Let me repeat again. Double click on BSc Sensex. That's the Corollogram which you get. If you want to see again the graph, you click on graph. And that's what graph looks like. And go to view again. And you will find a option of unit root. Okay. And if you see the graph clearly, you'll find a graph is having a trend. And it also has an intercept. I click on it. I say, okay. And null hypothesis is that series has a unit root. Let me copy it. If you see the null hypothesis is BSc 6 as a unit root, that means if it has a unit root, that means if as a row is equal to 1, then the series will be non-stationary, right? And look at the p-value, not rejected. That means the series is a non-stationary series. Okay, so I hope, is this clear? Any doubt, any query, any question? Let me go again to unit root. Then it says first difference. That means you are now testing if you take first difference of the series, whether it will be stationary or not. And when you take a difference, then series will not have a trend, it will have only intercept. So click on intercept, then you say okay. And now you can see And now you see the probability value is almost zero. Null is rejected. Null is rejected. That means series does not have a unit root, and therefore the series is a stationary series. Okay, and a similar exercise, friends, you can do when you take the return series. If I take the return series of Reliance, for example, unit root test, level, intercept, you will find 0. Null is rejected, and therefore the series is having a unit root. Okay, right? Any question? So friends, whenever you have a time series data, you have to do two things. One, make graphs of it. Okay, so when I say make a graph of it, that means make a time series plot and Corollogram, and you will get an idea about the behavior of the time series. Second thing is you check whether your series are stationary or not. If they are stationary, you can do further analysis. Otherwise, you have to make your series stationary. Okay. Another thing, friend, you must appreciate the behavior of autocorrelation and the unit or the stationarity of the time series. Okay. So if I make a Corollogram of this, what you see, no memory is being carrying forward. Autocorrelation has faded out, right? So it is not being taken from one period to another period, and therefore the series has become a stationary series. But if you take a non-stationary series like prices, for example, and if we see your Corollogram, then see, autocorrelation figure is not fading out. And that the characteristic of a non-stationary series. If your autocorrelation series is not fading out over a period of time, that means memory is being carried forward, and it will have a feedback kind of a mechanism. It will have more change, more change, more change, more change, and ultimately the series will explode and you will not get a stationary series. Okay, so by looking at the autocorrelation graph, you can get an idea whether the series is going to be a stationary series or not a stationary series. Okay, any question, any doubt? So what to do when a time series is not stationary? When a time series is not stationary, make it stationary by taking difference of the series. So like here, we have taken prices, and I can make it stationary by taking difference between prices of the period t minus prices of the period t minus 1. So if you take the first difference of the series, then it may be possible that your series has become stationary. And we have seen that by taking the first difference, we have made the series stationary. Now, friends, I have a question here for you. I have a series YT, and let's assume this is your price series, for example. And Sonia, this is a question for you. Should you take simple difference or should you take log difference? Yes, Sonia, tell me. Hardeep, bolo. Sujit, Mandeep Kaur, Sonia, they both are saying log. But why log difference? Why not simple difference? Anyone? Any logic? Hardeep, my question is to make a series stationary, I need a difference. And the issue is should you take a simple difference like this? Or should you take a log difference like this? That's my question. And Sonia, other people, Sujit are saying, Mandeep, they are saying we should take a log difference. But the question is, why log difference? Anyone? If the first difference in any case will give you transformed values, no doubt about it. But should you take simple difference or the log difference? No, Barshab, I'm not standardizing the values. It's not a standardization process. So I'm sorry. No. Ajay Singh is saying to make the things simple. No, that's not the reason. Hardeep is saying that I will be happy with the simple difference if it satisfies assumptions. I do not know which assumptions he was referring to. I don't know. Okay. Friends, we should go for log difference because of a number of reasons. And please, I'm saying we should go for log difference in the context of economics and finance. And friends, I am not aware of other discipline. Maybe their log difference may work, but as far as I am concerned, I'm having knowledge about economics and finance. I'm talking in that particular context. Okay, right. Log difference of prices gives me what? Any one of you tell me what is the interpretation of the log of the difference of prices? Finance people, please go ahead. Lakshmi, sorry, Yamini. Returns, yes. And more specifically, it represents continuous compounding return. If you take a simple difference, you may not get a meaningful interpretation of it. But when you go for log difference, I have a meaningful interpretation, and that's continuous compounding return. Second, log difference can give you what is called growth rate. So you have a meaning of it. And because of that meaning, you can get necessary, meaningful interpretation of the same. Besides that, log differences are having nice mathematical properties. And because of it, if you have to take a difference, take log difference. That will make much sense. Okay. So friends, to make this series stationary, take log difference. After learning how to test the stationarity of a time series, let's see what is the next thing we are going to talk about. Time to check our understanding. Okay. Augmented Dickey-Fuller test p-value is this. Series is showing the series is not stationary, having unit root. See the trend, okay, and it's not fading out, carries memory, and therefore the series is not a stationary series. Okay, if I take the return of it, log return, I get a series like this. No trend. And look at this ACF. You have a spike to begin with, but after that, autocorrelation is very, very, very weak. That means memory is not carried forward. And if the memory is not carried forward, then you are going to get a stationary series. And that can be verified from Adf test. Look at the p-value is 0.01. That means no unit root. Hence, the series is a stationary series. Okay? And here also, it is not fading out. You can immediately jump to a conclusion. Series will not be stationary series. And you can also verify it from Adf test. On the other end, if I take the log return of it, no memory, fading out immediately, you can immediately jump to the conclusion that the series is a stationary series. So friends, I hope by now you get a feel about stationarity and non-stationarity, how graphs can help you get an idea about the concept of stationarity and non-stationarity. Okay, and we have also get tests for stationarity. Adf test is one that is widely used, and be careful about your selection of the choices. And if a series is found to be not stationary, then by taking the log differences, you can make the series stationary. So any question, friends, before we proceed further? Any doubt? Okay. Having discussed about stationarity issues in time series and random walk, what is the next thing you have to discuss? And that is forecasting. And that will be discussed in the next session. Okay. So till then, have a nice time. And thank you very much for it, for being with me. Thanks a lot.
Thank you so
And
much,
the next
sir.
session we'll be going to talk about. Thank you. Thank you very much, Sonia.
Sir, actually, I just had a word with the
Yes, please go ahead.
I just had a word with the Pankaj Agarwal, sir. Actually, he cannot take the session in the evening. He had certain reservations. He's preoccupied somewhere. So probably we may change his session for the tomorrow evening. And I hope it will not disrupt in any way.
No, it will not.
Okay.
It will not.
Participants, it is informed to you that I'll seek the approval of the Pankaj Kumar Agarwal. He had a session on forecasting, which was planned today, but because of some preoccupation and the urgent assignment, it cannot be held today. If he'll be ready, we'll have the sessions tomorrow evening. Thank you so much, sir. Thank you for being with us.
Thank you. Thanks a lot.
We would like to have.
Thanks, participants, for being so interactive during the session, and keep interacting. And please make sure that you get clarity. You should not leave with confusion. Thank you very much. Thanks to all.
We'd like to have, sir, more session of yours where we can talk in much details in the times to come, sir.
Okay. Thank you. Thank you, Sonia.
Thank you, sir.
Thank you.
Thank you, participants.
So, ma'am, do we have any session now after lunch or not?
Actually, after lunch, we had a session. We have already informed you through schedule from 4:30 to 6. With
Yes,
Dr.
ma'am.
Pankaj Agarwal, he had a session on forecasting. But today he has certain issues. I just will have a word with him and will pass on all the information through your emails. Okay? If he agrees, will you inform you in the morning session? Tomorrow morning we have the session. If he agrees, we'll plan the session for the forecasting tomorrow evening. Is that okay?
Okay, ma'am.
Any other doubt, participants?
Yes, so ma'am, today's session is over.
Yeah, today's session is over.
All right, we are done for the day.
Good afternoon, Professor CP.
Yes, please, go ahead.
I'm audible.
Yes.
Professor, I just want to know if there is any good reference book for this thing that we can follow for our future reference.
Okay. I will share with you tomorrow. I will give the complete list tomorrow. Okay.
Okay. Thanks, Professor. Thank you so much.
Thank you.
Sonia ma'am, Sonia.
Yes, sir. Yeah, Ramesh, sir.
Yes, sir. I want to thank Professor. It was very nice lecture. I have enjoyed his presentations and I'm very happy. I was looking for his next session tomorrow. Thank you very much.
Yes,
sir.
sir.
Thank you for
Tomorrow
the
again we have two
appreciation.
sessions.
Thank you. Thanks a lot. Thank you very much.
Thank you, everyone. Enjoy your lunch, please. Have a good day. Bye.
Thank you, Dr. Gupta, a lot.
Thank you. Thanks a lot.
Sonia ma'am.
Yeah, I'm here, sir.
Yeah. Ma'am, yesterday's session, Dr. Gurjeet Kaur's session, that content will be sent later on?
Yes, sir. Actually, more than 450 participants have registered. Some are on YouTube. I do not know why the people are here, but we are sharing the content with everybody. My colleague, Dr. Gyan Prakash, I have forwarded all the things to him. He'll be sharing all the details with you.
Yeah, because I think the assessment is going to happen tomorrow.
Tomorrow evening, if we'll have the session in the evening session, then we'll send you the Google form on Saturday.
Okay.
Or tomorrow.
That you will confirm tomorrow, right?
Yeah, we'll confirm tomorrow.
And Dr. Gupta, this is Nilesh Kumar. Can you hear me?
Right. I'm able to.
I work as senior assistant professor with NMIMS University. I teach general management subjects and also research methodology.
Okay, good.
And
great.
so great to listen to you, and it was indeed a very fulfilling session.
Thank you.
Because
Thank
I have
you very
economics. I have economics background also. I did my economics honors from University of Delhi many years back.
Which college?
I was with Ramjas College, sir.
Oh, great.
Yeah.
Great.
Yeah, and I also have a management background. Thank you.
Okay.
Thank you very much.
Thank you very much.
Good
Thanks for appreciation. Thank you very much.